In this tutorial, we are going to focus on how pocket recognition can automatically find closed pockets within given parameters and apply toolpaths to these features. Here we have our part. In our first setup, we are going to machine the top features and then all of these side features. We already have the toolpaths for the drilling operations, and as they are identical around our part, we will do a circular pattern with 4 instances. To rough out these pockets, let's choose 2D adaptive clearing and apply the tool orientation and change the contour mode to pocket recognition. We can now see highlighted in yellow the pockets that have been found. We can see this large pocket is the only one that has been currently detected. That is because the smaller pockets have a corner radius of 3 mm. So let's adjust the search criteria and see the view update in real time to show the addition of these smaller pockets. Also, we can choose to include cylindrical holes on our part. Once again, let's take a look at our search criteria. On our model, these holes are 15 mm deep, so adjusting the pocket depth will now include these into our selection. We can now see that how simply adjusting these parameters either identifies or excludes the various shapes and size of pockets across our part. As these holes are drilled, let's uncheck include holes and create this toolpath. We have now got a roughing toolpath for these pockets, and most importantly, without actually having to select any geometry. This means that if you add more pockets, or even remove them, the toolpath will update parametrically when it's regenerated. Let's create a finishing toolpath using 2D contour. We can again use pocket recognition, and here let's use expressions to restrict the minimum radius by looking at the tool diameter and dividing it by 2 to give us the radius, and then let's add an additional 5% onto this value so I won't get full engagement on the corners. We can now see for this 6mm end mill only the larger pocket has been selected and not the smaller ones. We can duplicate this toolpath, change the tool, and we see the smaller pockets automatically selected for us. Limiting the maximum corner radius now prevents the larger pockets from being finished twice. Let's simulate in Fusion 360 and then over onto the machine. I hope you found this tutorial useful. Remember, using pocket recognition not only reduces time spent manually selecting pockets, but is far more resilient to model changes, as it's capturing your intent rather than a specific part of the model. You can even combine pocket recognition with the power of templates to streamline your programming process even further. Thanks for watching everyone, and see you all again next time.